So one of the things we talked about previously is this R2 calculation and how this ratio over here is derived. But notice here what we're doing is we are simply getting the actual price here, which is 200, and based on the average house price. And then what we do is we square the number and it gives you the square of that number over here. But these are this error rate of 25,000. So what we're saying here is if the average house price, yes, is 300 by user. So let's say, the street, and on that street, the following are the actual house prices. What you do is you divide by, to get the average, you divide by the total number of houses and you get a price of 300. If you ask somebody on average, what do you think the average house is worth on a street? They'll say, well, I'll take all the sum of the actual prices over here and then divide them by the total houses. And this would be your average price. And what we're doing here is we're comparing that against actual. And then we're saying this will be, square the number. And this is what we're saying is the error rate of the average. Yes. If you were to do the guess, then this is, what the error rate will be. And what you do is you compare it against the model error rate. So you can see the model is better at predicting. So if a house is worth 200, rather than just using the, average price of a house, so on the street, so rather than just using 300, what you're doing is you are actually using the model prediction, which is actually saying it, this house is worth 207. And the next one is 242 versus 250 actual. So this is the actual, this is the predicted. So again, you're squaring the numbers over here and then you get this output. But these numbers, when you get 394 or 25,000 over here, these are not dollar amounts. What you have to do is these are only for the R2 calculation ratio. They are not to be meant to say, you're off by, for example, $49,000 over here, because that's not the case. You're actually off by, $7,000 over there. So instead, what you can use is you can use from the sklearn metrics, you can import the mean absolute error and mean squared error functions. And what these will do is you get this mean absolute error and mean squared error. And the figures are pretty close over here. So mean absolute error is basically on your model prediction are off by this $1,000 from the actual price. So in this example, you can see we've got mean absolute error of 8.44. So what we're saying is we are off by $8,000 or so. Root squared error. This is the typical size of the error, also in $1,000, but bigger mistakes count extra. So it's slightly bigger than, and again, this is in thousands of dollars. Whereas, the calculation for R2, that's not in dollars. These are purely a ratio, to generate this R2 metric over here. Over here is where you can actually say, actually, my model is off by $8,000 on average. So you can use MAE, mean absolute error, for root squared error to actually, if somebody says to you, give me your modeled error rate in the actual, the data that you're working with, this is, so in our case, it's in dollars. So we can say it's off by $8,000 or so, rather than if you don't want to work with ratio, though you find understanding ratio is hard.